Hello guys, my name is Arun Tyagi and today I'm going to talk about a very important aspect of database design. System design is basically how you choose your database. So if you have followed any of my design video, right, like I have used Cassandra, some places I have used SQL, and normally when we choose that, normally we only talk about that because it was transactional in nature, or it was, I wanted to have something which can scale out easily, so I will go with NoSQL, and if transactional I'll go with SQL and blah blah blah. But if you are at this level, you know I'm assuming you are a mid-level or senior level engineer. If you are reading about these designs particularly, then you need to know the tech stack behind these databases, and also the data structure and all which are being used. So uh, when you will be talking about the database choices, there are chances that interviewer might want you to go a little bit deeper into it, why you chose something like that. So continuing the discussion, at this level, I'm assuming you might have heard of a book called Designing Data Intensive Applications. Uh, this one here on the screen. So you should have read it, right? If not, at least you should have known about it. This is very important if you want to go deeper into your database choices. You will be able to justify your choices if you know the underlying things going when you are doing any kind of a write or read in a DB or from a DB, right? So today I'm taking inspiration from chapter 3 of this book, which is storage and retrieval. And other than this, my experience so far. So if you want to read, go deeper into it, go and read that chapter. And I will definitely try to cover the interview side of thing of it, that how bare minimum how much you should be knowing when we are talking about database choices. And there are high chances that after this level, people will poking questions around why you chose this, how it will perform, why it will not perform if you would have chosen the other DB, and randomly throw some very weird problem statements to you, that if you have, for example, hundreds of DBs of some type of data and you need to query this kind of queries, then how you will perform it. So if we the things which I'm going to cover in this video, if we know this, we might have some answers uh, around those. Let's start with Cassandra, because I have uses Cassandra in most of my designs. So I'm not going to talk about Cassandra, but I'm starting from a database, and then I will come to underlying technologies, and I'll be able to cover most of the NoSQL's underlying technology with this. So first of all, where we should choose Cassandra, to be specific for now, when I'm having a scenario of, you know, my application is write heavy, which means wherever you think of, every second millions of users are sending a data to write towards the application. That is where Cassandra or other databases like Cassandra will be the perfect choice for you. Now, and actually, this is very fast. But why we are saying it is fast? Let's cover that first. So though we did not talk about, that these are like key value partition key based databases, but I'm assuming that much, we know by the kind of designs we did so far. So when a user is saying write something into my DB, what exactly is happening? Data is actually written into a log first. Why is that? Simply for durability. By that we mean, let's suppose your disk dies or in-memory data structure dies, you will be able to rebuild it. That is what we do even in our applications, right? We think of, if something behind this particular application dies, then how we will recover from it. So that's the first thing is happening. Then what actually is happening after it, the data is being written into an in-memory data structure, and that is called a memory table or a mem table. You can think of it that we are having a key and value. Value is nothing but a further key value pairs, where your key will be column name, value will be the value of that, right? So that is how this table should be. But the key aspect is this is in memory. So when we are issuing it, it is actually not writing everything into the disk. When this memory is full, or whatever my threshold point is for that database, what it is doing is then it is trying to flush it into the disk, and that is where it is actually storing in something like SSTable. What is SSTable? Your sorted string table, right? So now, so because strings are immutable, this is actually leveraging the same. So there could have been a sorted string already into my on my disk, and you got more data now. So what it will do is it will not try to sort that entire, it will try to build a new SS table. So whenever you are flushing a new SS table, so merging the old and the new, so creating a new SS table, that is when writing onto disk is happening. So why your write was fast? Because you simply wrote it into the memory and came back, right? And whenever it is full, so underlying DB is managing to write it onto the disk at once. So that's why the cycle, when it is happening, that is taking time, but it is not uh, stopping user to performing their actions. Now, and after that, so basically whatever complications and all are there, those are happening at your SS table merge level. Now, so the point I'm trying to come to is something like all the DBs which are running on SSTable, so SSTable which Cassandra use, but most of the DB which are, we call them LSM table based, right? So beat your the major cloud technologies, Azure and AWS, so they offer, like your Azure offer Cosmos, and under which it actually, under Cosmos, it actually offers you Cassandra APIs as well, plus like table storage, where you are having a the entire table, and you can use partition key, row key for the fast read and write. And in AWS, which is very famous, called DynamoDB, right? So all these works on LSM um, based data structures, but under the way of writing is exactly same what I tried to explain it here, which looks simple but way powerful. So think of a table like this, right? So basically what is happening is your data have to be something like a simple partition key is defined. Like here, I'm taking this as my key, where my user, one user 101, 202, 303. What I'm trying to show here is that is this 101, 202, 303 will always be stored in sorted manner, be it at mem table or in your SS table. So mem table is in memory, SS table is at the disk. That means you have to define your key upfront, and for that you need to know your query pattern, how you will query it later. Then only these databases will perform. That's the trick, right? Anyways, we'll come to that. So what we were saying is, first is your partition key, so that it directly knows where I need to go when I'm trying to write in a logical partition, right? And same works for when I'll try to get it. And like I was saying, under this key also, this is key value, how it's stored, right? So your column name is your key, and then the value of that. So name is my key and value is the same way, city and age, etc. Moving on, one more thing to notice, how it actually divides the data. It simply use a consistent hashing for that, right? And so what it does is, when you define your partition key, on basis of your partition key, it tries to distribute the data, right? And so all the issues of what if all the keys are going to be of same type and all those things, then one hash, or yeah, one particular node can be heavy and all. For them, the solution is usual, which we have for consistent hashing in any system. But the point I'm trying to come to, it uses consistent hashing to distribute the data into different nodes and physical nodes. That means every physical node will ultimately have a mem table and a disk, an SS table to store it, right? One more thing is about consistency. This is not consistent hashing, but I'm talking about whether you know your system should be eventually consistent, or it needs to be that every time value should be same in all the systems and all. So as at the database level, they simply give it configurable. So that means choice is yours, how you want it. For example, what choices we have for the consistency. So normally it's like one. So as soon as a user is writing something into the DB, and if from any of my server I get the response back that success, so I will consider it as success and I'm okay. Eventually it will copy it into all the locations and all. Second, it can be what quorum. So this is a simple algorithm which we use, right? Which is like, if you have 5 systems, you try to write, and if three of the systems give you the success, so 3 by 5 give you the success, um, that I will consider as my write to the DB is successful, right? Obviously, writing it into 1 from your application and writing it into 3, there will be a time difference, right? First one will be faster, but that is where the cost comes. What exactly we want? Do we want a highly consistent system, or do we want eventually consistent system, right? And last can be, this option is also there, write in all. So only when 5 out of 5 location return me as success, that it is returned into all of them, then only I will consider it as that my value is stored. Because when anybody will read it, everybody will get the same value, and it is not eventually consistent. This is like highly consistent. Obviously this will be on a slower side comparatively. So at the database level, this is basically they leave it at user uh, responsibility. How you want it, you can choose it. Baseline, when should we use a DB like this, which is SS table based? Simple query means, first thing, this is like a must have. You should exactly know for which partition key you are querying. Means you cannot query like, I want all the user where age is greater than X. So that means you ignored the partition key and you are simply want to filter from all the users. Those kind of queries, these DBs will never be able to perform, right? Then you want, uh, in simple, you want specific columns, or the latest row, what exactly you want with this partition key. And basically you don't need joins, subqueries, group by and all those things which we are used to in a SQL DB. Now look at these queries. So we are talking about get my user profile, where I'm exactly know for which user I'm querying, right? So all the profile things. Then something like fetch latest notifications. So here also what I'm doing is for this particular user, I'm trying to get all the notifications. So I directly know this partition key, and then what are my other columns that only where notification will be my row key or something like that. Another example can be IoT sensor data. So here also I know for which device I'm trying to get something. And shopping cart for a user, right? So these are my simple queries. So these queries for millions of record, hundreds of millions of record, these DBs will be way faster than our normal B-tree based, means our SQL databases. And to further highlight where these kind of DBs will not work, um, LSM tree, SSTable based. So think of that you have to scan the entire table. You don't know your partition. You don't know your global secondary index. There it will not work. Then if you want to join in multiple tables, right? For so if you want to join within DB and perform, it will be slow, right? Then things like aggregation, sum, average, and all those things, very inefficient. Like ad hoc filtering, like I gave example earlier also, where age is greater than this, it will not work. Indexing, your global partition key need to be given, otherwise it will not work. And another example is sorting over multiple partition key, right? So it will not work again. So sorting only works within partition. I can do sorting of order by age and all those things, but in one partition, otherwise it will not work. All right. So it is important to establish, finally, that in database which are dependent on SS table like data structure, first thing is they are immutable. Every entry which you are doing, you cannot edit it. There will always be append on it, and then ultimately it merges it with the existing DB. They are always sorted by partition key, hence it is easy to go to a particular partition key in the DB. It is indexed by partition key, right? So you directly from the index file, you directly know where to go. Within partition key, data is sorted. Then it writes in memory first. So like in SSTable in Cassandra, we use mem table first, and then it flushes into the disk when this memory table is full or memory is full. Hence, every time you are not writing into the disk. And on major cloud services, in AWS, we have DynamoDB. In Azure Cosmos, we have Azure Cosmos, which is offering the Cassandra APIs as well. These two are not directly SSTable based. Actually, they are LSM tree based, but the basics are same. That's why I talked about SSTable based DB. Cassandra is the major DB which is SSTable based available to you know uh, for us to use. So I'll not go deep into our relational database, but this knowledge need to be established that our B tree based DBs, so B tree, B plus tree, all the variants of balanced tree, those databases are our typical relational databases which we are using from a very long period, right? When to use it, that much we need to always have in our subconscious mind, that when if we need something like a range query, that on a given column you need values from x to y, all the rows where x to y is there. So that is one kind of a query. If your system is read heavy on a known on a known index, then also it makes sense to be on this side. That is where the tree will be able to give you data very fast. And obviously if you need acid, also not just on one table. Let's suppose you have relational, multiple tables which are joined, and you are simply saying that I need acid property on all those tables. So that is where only relational table will make sense. Our NoSQL will not work when you are having joins and you want acid on it, right? It is atomic on that one partition key, or you can say one particular row within that table. It is definitely atomic NoSQL, but on different tables it will not work. So our typical relational DBs uh, are to be used when we need all these things, heavy transaction, heavy things wherever you need it. And just to cover one last more thing here is they also mentioned as your OLTP, that is your online transactional processing. So all your DBs, say MySQL, my PostgreSQL, and your others, all comes in this category. So OLTP, we whenever we are saying OLTP, that basically talking about your transactional DBs. Those were the generic category we are talking about. Wherever those transactional properties, ACID properties are required, these are my DBs. Like blindly, I'll choose those. Next we have OLAP. So like name suggested, analytical processing. So whenever you have to do something on historical data, you have a lot of data and you need to query something on it, like for example sales trend, what happened in this month, people were buying what in that particular date range, people started buying what. These kind of queries you have to do, or think of similarly like customer behavior in different things, right? This was on sale, so in other things you might have uh, different kind of trends, right? Not in sales. So customer behavior, if you have to extract from the data which you are having, and that is a historical data, you have a lot of data, or different kind of dashboards you have to make, right? So wherever these kind of things you are having, and I would say, like we said in NoSQL, we were talking about simple queries, but here we are talking about complex queries, right? Complex queries, and that too read heavy, right? We are not talking about writes, but we are talking about very read heavy, in read heavy and aggregation wherever you have to do. That is where this analytical databases, I would say, processing is definitely required. What are the famous services available? So you might have heard of Snowflakes. uh, Wherever we are using it, that means for analytical things, we are using it. BigQuery is another engine for the same thing. And other than this, the famous names are, on Azure we have Azure Synopsys, if I'm not wrong. So likewise, major clouds are offering their services in different in the same bucket, right? So these, how do you normally do it? So when you are having a lot of data, or let's suppose data is coming from your services, a user is doing something, it is coming to your service, and then you are dumping into your normal DB, plus you are sending it to Kafka, right? Ultimately what you need to do, you need to extract that data, you need to transform it, and you have to load it into these systems in a particular structure. That is what we call ETL, extract, transform, load, right? uh, what exactly we are doing is, you need to, here also same as NoSQL, you need to know your query pattern, what kind of query you will do on it. Once you know it, you have to basically structure your data which is like performant for that particular query. So structure it and save it in that fashion, maybe on time series, or however you want it, so that you can extract it from it. So think of, you have a transactional data, like you have, your service is let's suppose banks are customers of your service. So you have hundreds of DBs from different banks. What that DB is having your typical transactions, right? That has to be on SQL, I'm assuming, right? If that is on those transactions you are already having, but you might need to your service now might need to query on give me data for a user on transaction types. Like here we have NTFS and all those, UPI nowadays. Same way in different countries, there are different ways of transactions. So get all my transaction of this type, get all my transaction of this type. These kind of queries you have to support. Or you have things like transaction within that range. So give me all my transactions from this date to this date. This is very frequent we do, right? If you have to support these kind of things but not on just on one DB, you have hundreds of DB, what you will do, that is where your OLAP will come in picture. So what you need to do is extract this data, transform it in the form you want it, and then load it in one of these big data systems, right? Analytical systems, Snowflake, BigQueries, and others. That is where it will help. Finally, this is a kind of a comparison table or a cheat sheet which can help us deciding which DB to use and when. Primary use case, like I said, real-time transactions. When you are storing, you will go with something like SQL, right? When you want analytical or reporting, right, that is where we will need something like Snowflake. And when you need a very high throughput and scalable, this should be, should be able to scale to a very, very big data, then Cassandra, NoSQL, right, your Dynamo and all those things will work. What it is optimized for: fast read and write both, but again, it will not scale. Fast read, but not like 1 petabyte of data can be generated from your application. Then large data scan, your OLAP, your Snowflake and all can definitely maintain. And when you need on that large data, you need aggregation. That is where OLAP will come in picture. And NoSQL, when you have high volume but key based access, you should always know for which key you are trying to get the data and for which key you're trying to write the data. Then only these are optimized for, right? Then, like I said, data volume, your transactional, your normal relational DB can go till TBs, but that there also it will not perform. Beyond it, no way, right? Then your both NoSQL plus your aggregated, DBs which aggregate can go till petabytes easily. Uh, it's not about storing; they will perform with that kind of huge load. Then schema wise, obviously our SQL is strictly, you have to define that entire structure, then only you will be able to save and get the data. In OLAP, it's like semi-structured, so you have to define, like we said, transform it in which structure you want to save. So it kind of semi-structured but still flexible, you can change it easily. And NoSQL, definitely no structure. As soon as you know your key, inside it you can dump anything. Finally, joins. We know in transactional, in MySQL, join works very well. In OLAP also, because this is like SQL-like only query. So there also join will work and it will be able to perform. In NoSQL, definitely no. Right. Then aggregation, wherever we need it. In our normal DBs, in our SQL, MySQL, it works, but not to a scale. You cannot, like in petabyte of data, I want a range, this and that. It will definitely not work, because if indexing is not there, it is ultimately what you are doing, you're scanning the entire table, hence it will not perform. But basic, it will definitely work. Aggregation, that is actually made for it. So wherever you need aggregation on a big data, this is the choice of your DB to go ahead. then in NoSQL, I would say no, we cannot do any range aggregation and all. Now comes to latency. Obviously, your DB, your SQL performs, but the data size have to be small. Then your OLAP is made to be work on big data, so it is slightly on a higher side, but that is because it is working on a big data, right? And on other hand, on NoSQL, even on big data, it is very fast. Reason behind that is obviously your queries have to be simple. You have to know for which key you are trying to get. That is where it is very fast. Now coming to your data model, uh, relational table rows, we are used to of seeing it in your OLAP. It is stored in basically your compressed manner, because huge volume of data we have to store, so it has to be compressed. I didn't talk about columnar though. I'll talk about it in next section. Then in NoSQL, most of the time it is key and value, right? And that is how it is structured. Then for your consistency, our SQL have to be like highly consistent. Once you write it, it is there in your DB. uh, OLAP, it is mostly eventually consistent. It can also be strong if you really want it, so you can do it. Obviously performance will hinder, and like we discussed in Cassandra, it is like as per the user how you want it, right? In SQL it is always highly consistent, but in NoSQL you can tune it. It depends on your application. If you want it highly consistent, you can do it, but obviously it will be uh, the performance will be lower of your write performance. So but you can tune it. All the options are available. It can be quorum, all, or only one. Scalability, that is where normally, that is why in fact NoSQL and all came. It cannot scale. What do you mean by that? Whenever you will go about having the same data in different, I mean same application data in different locations, because one of your table, for example order table, grew a lot, right? And that it has to be broken into two different servers now, two different data centers now. That is where your application will become very complicated, difficult to maintain, right? Because here we are only talking about one table, so we'll say okay, we can have different charts, we know for which to go where. But when you will think of your entire data structure, all the tables, then you have to break it in such fashion, it will not you will not be able to scale out like that. On other two systems, that is where they shine. You can easily break them because they're like acid at a granular level, so you will be able to break right into different DB, use consistent hashing for for which key I need to go to which data center. If you know that much, things are easy for you. You will be able to scale out easily horizontally. Examples we know in our SQL, we have MySQL, PostgreSQL, Oracle, and all. In OLAP, Snowflake, very famous, BigQuery, Redshift, and your Azure Synapse. In NoSQL, Cassandra, DynamoDB, MongoDB, Cosmos on Azure. These are our major services available. Use case for systems like banking, where you need actually that consistent transaction, your ACID property have to be followed. So there blindly we have to go on something like SQL. And normally we go hybrid, right? In banking, some of the tables are like those need to be scale out, and high ACID property is not required, so that is where we use combination of SQL plus NoSQL. Anyways, so your business report, dashboards, like we discussed earlier, that is where your OLAP is in picture. Whenever you know your key, your partition key, that is where basically NoSQL will shine, right? Your write pattern is row by row in this. In SQL, in OLAP, it is like batch. In batches, you can dump the data, and in NoSQL it is append only. Like you said, it's immutable. So for high write, that is why it is chosen for whenever you are having heavy write requirements, that it will always append the data, and that is, even then it will be able to maintain the structure for fast read, right? Read primary key lookup in your SQL as well. Full table scan in OLAP only you will be able to do, and partition key based uh, fast lookups you can say in your NoSQL. So these are the major key differences which we are having. So keep those in mind when you are choosing a DB or when you are discussing about these technologies in your interview. So last thing I said I'll cover is something like columnar. All your Snowflake and wherever you need aggregation, those are actually columnar based DBs. What that means? So in your simple transactional DB like MySQL, what do we do is we store data row by row. So for example, my row is my user ID is my key. Then you are having like name of the user, then you are having age of the user, and several different things, right? So you will, how you will store it is like one, then my name is Arun, then my age is whatever XY, right? So same way, one by one you will store it. But if you need things like aggregation on a column, right? Average, sum, all those things we talked about, trending, right? So that means on particular column you need it. So how it actually store the data? What it does is, rather than storing it like to some alpha and ABC, right? Rather than storing it like this, what it does is, so store it in columns. So you will always have user IDs, and you will store one comma. So it will be like this. Imagine it like an array. Then you will have another array of age, right? So you will have 28, 32, blah blah blah. This is another array. Likewise, there are multiple arrays, right? So if you are storing it in columns, if you are storing columns, then think of, if you have to query, give me all who are greater than uh, in a range of from 25 to 35, all my users. So what you will go do is, you will directly go into this column, get all those indexes, right? That means now you have those indexes in your answer. So you will prepare an answer, and you have that my indexes are say 5 comma 10 comma 15, and it will always be sorted because that is how you chose this. Same way, then you will be able to, from these directly on these indexes, you will be able to read other values like my user IDs, my names, and all those things, right? So that is where storing it in this fashion will be able to give you those answers very fast. So that is normally on a very high level. We call it columnar because the data is stored in this way. I think that is about my DB choices and very high level understanding of how we store the data in these kind of technologies and how we retrieve it and why we chose any particular DB or any particular service for which kind of in my high level design, right? So that's it. Thank you.